Okay, good morning everybody. Thank you for joining this webinar. I think we have a good audience that decided to participate. I'm going to talk to you today about the very exciting new direction that Henkel Loctite have taken with these hybrid adhesives, and hopefully you'll find something of interest to you. Just a little bit of housekeeping. I expect the presentation to take about 30 minutes. There'll be an opportunity at the end for some questions and answers if you have that. From a housekeeping point of view, keep your computers and whatever in listen only mode. You can control the audio function if you like. You can type your questions into the question chat box, and we are making a recording of the webinar, which I guess will be put online and available to you if you choose to go back and revisit it. Okay. So, just a little bit about myself. I've spent my whole working career with industrial and engineering adhesives. You can see A by the photo and B by my picture that represents a number of years, which we shan't discuss in too much detail. But I've a lot of experience, and I've been leading the launch of the hybrids into the UK. The first thing I want to show you is a short video, but I'll do that as soon as I've gone through the agenda. So it's going to be a simple agenda, deliberately simple. I want to give you some market background. I want to explain to you in some detail how we've arrived at some of the properties associated with the products that we've launched. It's not been by accident. We've listened carefully. So I want to go through some market background with you. I want to talk to you about some of the technology behind these new developments. And then I want to show you briefly some of the key properties and introduce you to the range of hybrids that we're launching, and then you will have an opportunity for questions at the end. But before we do any of that, I wanted to show you, and some of you may have seen this already, it's been widely publicized, a very short introductory video which Loctite had put together within the launch of this program. Now, the video may come through as a little bit jumpy, but hopefully it won't spoil too much the enjoyment for you. So let's give this a go. I just need to play.
3 grams of adhesive. 1 hour. 208 tons. Only one brand can make that math work. Loctite. Universal structural bonders, so strong, versatile, and durable. There's no limit to what they can do.
Okay. Hopefully that's whet your appetite for what's coming along. So going back to the agenda, I'm going to start with some market background. And I think it's very important that we do spend a little bit of time on this topic, because Henkel, like lots of other companies, do invest a lot of time and money in developing products, and very often those products are developed specifically for one customer. They're developed based on a particular customer needs. In this instance, what we've done is we've listened to the market involving structural bonding and structural assembly, and based on the collective voice of that marketing information, we've come up with this series of materials. So I want to run through with you now what those messages were that came back several years ago now, because this has been this has been a program that's been 3 years probably in development. So we wanted to know what were the trends and what were the drivers that the industry saw. They all agreed that there would be an increased demand for high performance structural adhesives. And we wanted to really delve into that to find out what were the things that perhaps were currently holding them back based on the current selection available to them. None of this, I'm hoping, comes as too much of a surprise to you, but I want to go through these points one by one. And the first one undoubtedly was, this message was, we see lightweight constructions becoming more and more significant. The two examples we have here, the top left, now that's top left as I'm looking, so I'm not quite sure if that's top left as you are. Okay, so this is a new leaf spring suspension unit for Volvo, and that involves a different Henkel product, as it turns out. But the point that Volvo were driving towards, excuse the pun there, was that they were able to take 4.5 kilograms of weight out of that construction, which obviously in automotive terms is a huge improvement. The picture on the top right classically shows a combination of high performance materials, carbon fiber, high performance composite foam, we have glass reinforced plastics. All of these materials are required to be joined together, and therefore we need adhesives to do that. And all of that drives this desire for more lightweight construction. Secondly, manufacturing cost and manufacturing time. It comes again as no surprise that everybody viewed the need to reduce those parameters as being crucial if the use of adhesives was to be increased going forward. Everybody is trying to reduce their work in process. Everybody is under significant cost pressure. It's a very competitive marketplace, and so people are trying to do things quicker, smaller footprint, that type of thing. And this one links probably to the first point, to our lightweight construction, but we are seeing new and different enabling substrates coming through all the time. And these materials evidently need to be joined to other materials. We now have things like carbon fiber and glass filled aluminium, for example, which is being used. We don't want to start drilling holes in these new high performance substrates in order to be able to join them to other materials. So new combinations coming through will be driving which adhesives are used in the future. And if we have materials that can join across multitudes of substrates, then evidently that enables us to grow the business of structural bonding. And finally, we can't ignore the pressure that businesses are under from in terms of improving their green credentials. Many of the currently available high performance adhesives, whilst they do good jobs, none of them can be considered to be, if you like, particularly green. And so this whole development process all the time had an eye on what's the labeling going to look like, how are they going to smell, what's the impact going to be like to people in the workplace that are going to be using them. So those were the messages that we got from the surveys that we did 3 years ago. How's that translated into what we've done, and what range of products do we have? Well, we saw our vision, if you like, our why vision, And we knew that there were opportunities missing from our existing range of adhesives. So we wanted to try and bring together a combination of materials, of properties. And how were we going to do that? By launching a range of materials that brought these new benefits to the marketplace. And again, the emphasis here is on range, because we have 3 products to talk to you about today. There will be a 4th arriving in the next quarter or in Q1 of 2018. And I think we see this as the way forward for development. And I'll elaborate on that a little bit as we go through. And what were we going to do? Well, we were going to launch this new technology. And the key point here again is global. These materials are available in every region around the world. It's been a completely joined up set of thinking. So we've had to be mindful about things like different health and safety legislation, different labeling requirements in different regions. So this really is a global launch that has taken place this year. So I'm going to talk to you now a little bit about the new developments. But before I do that, I'm just going to talk through what we currently have, because we have this whole range of materials, and irrespective of your view on what your precise definition of structural bonding might be, we've got all of these materials here that we can offer, ranging from rigid bonding on the left-hand side, the really high performance one-part epoxies, stiff materials, right through to the silicons on the other side, very stretchy, used for elastic bonding. And we have all of these advantages from all of these different technologies. However, of course, life's not as nice as we'd like it to be all the time, and all of those materials do come with some disadvantages. And it's our job as technical people within the adhesives industry to try and overcome some of those disadvantages and work with customers to make sure that the products they've selected work to the best of their advantage. But all the time that we're developing within these silos, we're always going to roughly have the same set of disadvantages. So yes, we can change viscosity, and yes, we can change setting speed a bit and so on, but fundamentally our single part epoxies are not going to bond to plastic very well, for example, and fundamentally our polyurethanes might need priming for bonding to metal. So all the time we're in these silos, our freedom of development is somewhat restricted. Now, one way to look at that is this chart we often use, which shows the relative positioning of these different technologies. And we have our vertical axis, which is our performance, our strength, and our horizontal axis, which is how stretchy are these materials. Now, you can see that obviously these products occupy the sort of the bottom left quadrant of this chart. No one, to my knowledge yet, has been able to make something that's highly stretchy and very, very strong as well. But there's a desire to populate this white space on this chart. Now, we're coming through with some exciting new polyurethane materials, and hopefully next year I'll be giving a webinar on those. But today we're focusing on the hybrids, and the whole intention here is by combining different technologies together, we can start to populate that white space and gain advantages that up until this point we haven't been able to do. So what have we done? Okay, so we've taken as a basis to begin with cyanoacrylate technology. Now, if you think about what cyanoacrylate brings to the table, it brings adhesion to different substrates, particularly plastics and rubbers. It brings speed of set, It brings durability on plastics and rubbers. But if we combine that with methacrylate, what does methacrylate bring to the party? Well, methacrylate brings toughness. It brings performance on metals. It brings long-term durability in harsh environments. So if we were able to bring those two technologies together and overlap them to some degree, you can see how we're starting to build a product that has a very unique set of characteristics. And equally, if we start with the cyanoacrylate again, but this time we try and add in epoxy, what does the epoxy bring to us? Well, we know it brings fantastic strength. We know it brings brilliant performance on metals and long-term durability. So by combining cyanoacrylate either with methacrylate or with epoxy, we're able to start bringing products to the marketplace that have different characteristics. And so what are the four things, as we see it, that are the key value drivers? Well, it's not surprising really that what we've ended up with match the original points that were raised in the marketing discussion. So multi-substrate adhesion from these materials, it means we can reduce weight, we can reduce material costs, improve reliability. We have a fast cure from these systems. Evidently, we've started with the cyanoacrylate formulation, so it's not surprising that speed of set is one of the characteristics. It speeds up production, it reduces our work in progress, and that leads to more efficient manufacturing and reduced costs. Our third key point with this technology is we have this strength and durability. The more we can widen the performance envelope with higher temperatures, better chemical resistance, improved durability, the more people are likely to be adopting these types of products for their assembly processes, or at least consider them in the first instance. And again, picking up on the marketing information that was clearly communicated to us at the beginning of the program, we had to be certain about having a product or a range of materials with an improved health and safety aspect. Reduced risk, reduced health and safety concerns, and that simplifies the cost assessments. It reduces the risk to the workforce that are exposed to the materials. So we're very pleased with the overlap that we have between the actual finished articles that we ended up with versus the messages that the marketing survey and the marketing work actually provided us at the beginning. Okay. Just on that last health and safety point, you can see this sort of heat map here of hybrids against methacrylates and epoxies and polyurethanes. And you can see that the hybrids are performing significantly better than these other technologies. And so even for people that have already had their eyes opened to structural bonding, could well be thinking that there is a significant advantage here in changing technology in order to mitigate and reduce the risk. Okay, so there's a little bit of background about the marketing, about how we went about producing this program. Now I'm just going to spend a few minutes on just looking at the products at a very high level. There's loads and loads of data being generated here, which will be available through technical data sheets and more information online. But I want to just give you a high level view of what we have. So, see that there's 4 products there. I'm going to talk to you just today about 4070, 4080 and 4090. 4060 is a product that will be launched end of this year, Q1 of 2018. So to begin with, you can see that we've got 4070, which we've put under our maintenance and repair banner, and we have 4080 and 4090 in general assembly. Now, that's driven mainly because of the pack size, but there's absolutely nothing stopping anybody from using any of these materials in any application that they seem fit. And because of the dispensing equipment group that we have here as well, they can help you automate any of these in terms of application or dispensing. And so just with the 4070, I just want to show you this product first. You can see that it comes in a ready to use syringe with a double plunger here. And so it's why we've sort of targeted it towards the maintenance and repair. We believe it's a product that every maintenance and repair engineer ought to have in his kit for repairing all sorts of different materials. And you'll see as well, beg your pardon, that we have a 10-to-1 ratio. The piston sizes are different. So we have a 10-to-1 ratio there. Then with the 4080, we have a 50 ml cartridge here, 1-to-1 this time, sits and fits into a standard 1-to-1 handheld applicator, or indeed you could use pneumatic guns and so on. But these products, the assembly products, are also available in larger 400-gram pack sizes as well, which is why they're more aligned, if you like, or can be more aligned to bigger assembly processes. And finally, the 4090, again, same sort of pack size. You can see there, fits into the same sort of gun and also available in 400 grams. Okay. So let's have a look at the 4070. Ultra fast, universal repair, but again, you could use it for assembly. It doesn't have to be a repair adhesive. Bonds virtually any materials together. You have fast fixture speed, rapid strength development. It's great on substrates, including metals, plastics, and rubbers. We've really been able to bring together multi-substrate capability. We have a beautifully thixotropic, non-drip type of material. We can do upside down repairs. We can do large gap filling applications. And because of the thixotropy, we can take what is effectively a poor design. I mean, if you're thinking about repair, we've never designed it to break in the first place, but we can take a bad design, and by using the thixotropy of the product, we can improve that design as well. We've got good performance, good durability, and all of these hybrid technologies are patent protected. So looking at some data, look at the fantastic data that you see there in this column here. We've got fantastic performance on shear strength on steel and on aluminium. Anything greater than 22, 23 megapascals is really considered to be high performance structural bonding. And at the same time, we have substrate failure in polycarbonate, in ABS, acrylonitrile, and in nitrile rubber. So we've got a fantastic cross-functional surfaces here, great capability, great bond strength. And we've already highlighted the fact that from the labeling, we have a superior product. So the 4080, so this is also hybrided with acrylic, with methacrylate. This time we have a slower cure speed. It's still fast, but not quite as fast. Evidently, in the same way as we have freedom of design when we're designing and developing epoxies, with the hybrids we have freedom of design as well, and we can change speed of set, we can change viscosity, and so on. But this one, we have a tougher product and we have much better resistance to shock loading. Again, we can fill large gaps, unique hybrid technology. But what I really want to focus in, so here's another set of data. Again, you can see we benchmarked this against other typical high performance products. We have great strength on GBMS, great grip blasted mild steel, on aluminium, also on polycarbonate and ABS, and substrate failure on nitrile rubber as well. But the key property here that I really want to emphasize is this elongation property, 80% elongation to failure, which for materials like epoxies and similar, we don't have anything like that capability within the epoxies or even really within the acrylics. So again, very new set of properties that we're able to bring by having these hybrids. And then lastly but not least, 4090. Now this is a material which is hybrided with epoxy, and because of that we see it as a really tough and high performance material, probably bringing together the highest combination of properties that we're able to do, and also being able to bond to, again, metals and plastics and rubbers, which if in the past you'd have to sacrifice performance against plastic if you were going epoxy, for example, versus performance against metal. Here we're able to say, no, this is a material that's able to give us great performance on both. As I say, there's lots of additional data associated with these products, which evidently we don't have time to go into now. So if I just, again, give you a snapshot here, a summary of these 4 products as will be by the beginning of the new year. The 4060 and the 4090 are both our hybrid cyanoacrylate and epoxy, and our 4070 and our 4080 are our hybrids, which are a combination of cyanoacrylate and methacrylate. Use them against any application, whether it's manufacturing or whether it's repair. We see a tremendous opportunity for these materials in all sorts of areas, particularly I think where we have perhaps an awkward combination of surfaces. We're very confident that we can tackle these applications now with the hybrid products. This allows me to move into our question phase, which my very attractive assistant, who you can't see on the screen, will be happy to take. And so we'll take any questions that you may have, and then I'll just give you a couple of bits of information at the end as to where you can source additional information on the hybrids. So we have a question, which I will need to put my glasses on for. So the question is, can we use primers with these hybrid materials? The answer is we can. Evidently, what these materials don't do is they don't bond to very low surface energy plastics, for example, without treatment. We haven't fundamentally changed chemistry from that perspective, but yes, they can be used with primers. So what does the GY stand for? The GY stands for grey. Perhaps I should have mentioned that earlier. So in this instance, with the 4080, we have a white product and a black product, and evidently that gives us a nice visibility in terms of quality and mix. Okay, so I think, just checking that that's probably the end of the questions. Is there one more coming through? Glasses on again. So the question is, would we be prepared to come into any manufacturing facility and do demonstrations with these materials? And the answer is quite simply yes, we would. So if anybody has any desire to see them, if they have any applications in mind that are new, if they have any applications where they're currently using an adhesive but think that there might be additional benefits by moving to hybrids, be more than happy. Just get in contact with us and we'll get somebody to come in and demonstrate these materials to you. No problem with that at all. Okay. So that was our questions. There are 2 places that you can get additional information from: the website loctite.co.uk, or if you have a current application that you'd like to discuss or an opportunity, the technical helpline number is there in front of you. Just draw your attention to the picture of the train on the computer on the left-hand side there. There is a follow-up video to the one that you saw at the beginning of this presentation, which is effectively a behind-the-scenes look at the making of that short video. It only lasts about 4 minutes. We didn't want to run it in this webinar in case we had some downloading issues and IT issues, but you can find it on the website, you can find it on Google, and it's quite an interesting look at how that whole video was put together. So on that point, thank you for joining. I hope you found it interesting, and we'll be doing another webinar soon. I'm not quite sure on what topic, but hopefully I can chat to you then as well. Thank you very much.